Welcome. Today we're going to look at reflections, 2.2. We're continuing our unit on transformations. We looked at 2.1 is translations. 2.2 here now is reflections. We're going to explore reflections. We're going to look at reflecting figures, drawing reflections on the coordinate plane, and looking at lines of reflections. So first off, we have been doing a little bit from 1.3. Again, this is a topic that we talked about. 1.3 is we're going to find the unknown coordinates for each transformation using the rule provided. Our rule that is provided is given the coordinates x, y. Our rule is going to be negative x, y. Negative x means the opposite of x. So I'm going to take when I apply my rule, I'm going to take each x coordinate and take the opposite. Now, you will notice in the first point, R, the x coordinate is negative 4. I'm going to take the opposite of negative 4, which means I'm going to take the negative of negative 4. And remember, two negatives make a positive. So therefore, R prime is going to have an x coordinate of 4. For S, the opposite of negative 1 is the negative of negative 1. Remember, two negatives make a positive. It means S prime will have an x coordinate of 1. T, which has an x coordinate of negative 4, the opposite of negative 4 is the negative of negative 4. Again, two negatives make a positive, so that'll make it a positive 4. The y coordinate is going to remain unchanged. R had a y coordinate of 3, stays as 3. S had a y coordinate of 3, stays as 3. T has a y coordinate of 4, T prime becomes 4. My new image has the points R prime at 4, 3. So if I graph this, 4 to the right, up 3. S prime is 1, 3, right 1. Up 3 is S prime, and T is found at 4, 1. Right 4, up 1, will become T prime. Connect those 3 points to get my triangle R prime, S prime, T prime. What you will notice is this transformation is a reflection across the y-axis. The y-axis being the axis that runs straight up and down. And it's a reflection over that y-axis. So, remember back to last class, we defined a rigid motion. Rigid motions were transformations that change the position of a figure without changing the size or shape of the figure. We did say that translations were rigid motions in 2.1. Well, looking at the image we just did, it appears that the reflection we did had the figure be in the same size, the same shape, but it changed the position. So yes, reflections are also rigid motions. We're going to explore those a little bit more. Some of the properties of rigid motions, again, preserve distance, preserve angle measures. They also preserve betweenness, collinearity, and parallelism. The two keys in rigid motions is that they preserve distance and angle measures. On the next slide, we're actually going to look at this and compare this. Remember, we talked about translations, and translations preserving distance, or translations preserve orientation. Well, reflections do not preserve orientation. This means that all the order vertices of both the pre-image and the image are the opposites. One of them will be clockwise, while the other ones would be counterclockwise. And if I do look back at my previous slide, you will notice triangle RST. If I looked at it, the order there is clockwise. While R prime, S prime, T prime goes in the opposite order which is counterclockwise. So reflections do not preserve orientation. Now we talked about, does it preserve distance and angle measures? In your slides, you will see this, in your notes you see this slide. The pre-image triangle PQR is graphed for you. It's the blue triangle on my screen below the x-axis. Triangle P primed, Q primed, R primed is the triangle above the x-axis, which is red on my screen. What's the coordinate rule? Well, what's happening to the coordinates? I'm starting with the point x, y, and when I did this reflection, what did I do? Did the x coordinates change at all? No. So my rule is going to remain as x. Did the y coordinates change? Yeah. They became the opposite. They were negative, they're now positive, so my rule will become x negative y. Next in your notes it says, use GeoGebra to find the length of each side and to find the measure of each angle. We're not going to actually have you use GeoGebra, but what I did is you'll notice on my slide here is I use GeoGebra to measure the distances, the lengths of each side. And you will see them as you see my screen. They're measured there and the measured this side. PQ has a measurement of 6. QR is 3.6 units. And PR is 5. If I look up at P primed, Q prime, from the red triangle above the x-axis, that is 6 units as well. Q prime, R prime is 3.6. P prime, R prime is 5 units. And what you will notice is that corresponding sides have the same measurements, which shows me that a reflection preserves distance. Then it asks us to use GeoGebra to measure the angles. You will notice I have all 6 angles measured here in the picture. Angle P is 36.9 degrees. Angle Q is 56.3 degrees. Angle R is 86.8 degrees. And P prime is 36.9 degrees. Q prime is 56.3, and R prime is 86.8 degrees. Again, you will notice the corresponding angles, the 2 P's, the 2 Q's, and the 2 R's all have the same measure. So again, it shows that reflections do preserve angle measures. So getting into 2.2. We're going to explore the properties of reflections. In your notes it says to draw a segment to connect each vertex of quadrilateral ABCD with its image. So if I connect the points, I'm going to connect A to A prime, B to B prime, C to C prime, well, they're both on the line, so I don't need to really connect them, and D to D prime. It then says use a protractor to measure the angle formed by each segment and line L. If I get out my protractor here, and I bring it down, and rotate it here, what you will notice is that I've got it on the edge. The green line, if I extended it up, goes all the way up to 90 degrees. If I slide my protractor down to put the points where A primed, the middle green line intersects it, again, 90 degrees. Slide it down as well, again 90. So what do you notice about the angles? They are all 90 degrees. Then it tells me to use a ruler to measure. I've got my ruler out here and I adjusted it so it should match up with yours if you measured this in by hand yourself. So I'm placing my ruler to measure the distance from D to D prime. And what you will notice is it is about 2.6 centimeters. Well, if I measure the distance then from D to the black line, line L, which I reflected my image over, you'll notice I get 1.3 centimeters. And if I measure from the black line to D prime, again, you'll notice what? 1.3 centimeters. If I measure from A to A prime, okay, I get about 4 centimeters. And if I measure from A to the line of reflection, there I've got 2 centimeters. And from the black line to A prime, again, 2 centimeters. And if I measure from B to B prime, I get about 2.4 centimeters. Well, from B to the black line, I got 1.2. From the black line down, I get 1.2 as well. So what did I notice? Well, what I noticed is that the point where each of those lines that I drew in and connected corresponding points, they're all midpoints. They're exactly halfway between the corresponding points. So what we have noticed is that the line of reflection is what we call the perpendicular bisector of the segment that joins corresponding points. Its reflection question says a student claims that a figure in its reflected image will always lie on the opposite sides of the lines of reflection. Do you agree? Why or why not? No. Each point will be on the opposite side, but it is possible, okay? However, not every point will be on the same side of the line to start with. Also, it is possible that a point could be on the line of reflection. So some terminology. So remember, this is review. Perpendicular lines are lines that intersect at right angles. So if I draw two lines, they intersect, they will form a right angle. A perpendicular bisector is a line that's perpendicular to a segment at the midpoint of that segment. So if I have a segment here, and I draw the perpendicular bisector of that segment, it's going to be 90 degrees. It will also cut that segment in half, and that those two distances that I marked will be congruent or have the same measure. And the line of reflection, as I pointed out earlier, is the perpendicular bisector of the segment that connects corresponding points. And lastly, our definition for a reflection says a line across line L will map a point P to its image P prime. So if I have a line of reflection, if I reflect point P, it'll be on the other side. If P is not on the line L, then line L is the perpendicular bisector of P prime. If I join the points, they will be perpendicular, and the distance from P to the line of reflection and the distance from P prime to the line of reflection will both be the same. If point P is on line L, so if I draw another point P, if that is on line L, that same point is also P prime. It'll become the exact same point. So in example number 1, we want to draw the image of triangle ABC after reflection across line L. So I'm going to draw a segment with an, so in order to draw the reflection, I'm going to reflect triangle ABC. I'm going to draw a segment with an endpoint at vertex A so that the segment is perpendicular to line L and it's bisected like line L. Well, first thing what I'm going to do is I'm going to take, and I'm going to take line L here, and I'm going to trace it here to extend it out, okay? And I have a protractor here looking similar to what? I got a picture of it, copied it out. I'm going to place my protractor, so what you will notice is that the line L is perpendicular. So the edge of my protractor is perpendicular. I'm going to start off, it's asked for vertex A, so I'm going to go to point A, and I'm going to measure how far point A is from the line. And what you will notice is that A, my line in the middle, is at the 5 centimeter mark. So if I count over, I've got 1, 2, 3 centimeters, because A is at the 2 centimeter mark, which is 3 centimeters away. So I'm going to draw a line. Now I'm using the line tool here to do this. Okay. So I'm going to trace the edge of my protractor so it goes up. And what I'm going to do is draw it 3 centimeters to the other side. So from 5, 6, 7, 8 centimeters, there's my point A prime. Then next I'm going to go down to point B. So I'm just going to slide my protractor so the edge goes. And again, I'm going to draw another line. And as I measure this, I get that point B is about 0.8 centimeters away from it. I can see it's not quite to 4, because 4 would be 1 centimeter away. So it's about 0.8, it's 8 tick marks. So I'm going to count 8 tick marks. And there's my point B prime. Drag my protractor up to C. Again, I'll draw another dotted line here from C. And as I measure C, C is about 1.9. It's not quite to 3. So it's about 1.9 centimeters away. So I will measure 1.9 the other side. So starting at 5, 6 is 1. There's C prime. So I have A prime, B prime, C prime. Then what you should do is use your ruler to draw straight lines to connect those 3 points. In Notebook, I'm going to use my line tool to do that instead of drawing the straight lines. So I've got straight lines instead of drawing them. And there's my reflected image triangle A prime, B prime, C prime. How can you check that you drew the triangle correctly? Measure that the distances are the same distance away. Now it says your turn. Copy triangle ABC and line L in according to grid. Well, it's on your notes. You already have it there. You want to draw the triangle ABC after a reflection across line L. Even though there's a coordinate grid here, we're going to do this the exact same way we just did the one before. So you can try it on your own here. I'm going to copy my protractor. So I have it here. I'm going to take my protractor and rotate it. So then my protractor is that the line is 90 degrees. So I do need to take my line, extend it out so I can verify that. So I'm extending that line out. And what you'll see here is that my line. So the edge of my ruler part is now perpendicular. So that line of reflection goes from the center point all the way up through the 90 degrees. And then measure how far each point is. Point A looks like it's 1.6 centimeters away. So I'll measure 1.6. There's A prime. I do want to trace that. So I would trace the edge of my ruler to draw the line of reflection there. I slide my ruler down. What you'll notice is that B is about 1.7 away, so I'll measure 1.7. There's B prime. Again, I'll draw the line that connects them. To do that, and then C, what you'll notice here is C is on the other side of the line, but it doesn't matter. So C is, if I measured, I got 1.7 centimeters to the right of the line. Well, I'm going to put C 1.7 centimeters on the left. Now, if I trace the edge of my ruler to draw the line, that shows it. Now, one thing what I do want to do is I also want to show my markings to indicate my work. Well, I'm going to mark that these distances are the same by putting slash marks, and I also will mark that these angles are 90 degrees. Well, my final answer here is then to connect my 3 points, A prime, B prime, and C prime. And remember, we used the prime to indicate that it was that point reflected. So the red triangle you see on my screen, triangle A prime, B prime, C prime, is my image. The next thing that we are going to look at here is we're going to discover some coordinate rules on the grid. So it says using GeoGebra. Well, you will notice in your thing, you're not going to actually use GeoGebra. We use GeoGebra to get the graphs. We are starting with triangle ABC, which is the blue triangle on my screen. Yours is in black and white, but it's the blue one, which is above in the top right there of the coordinate grid. This triangle was reflected across the x-axis to get the red triangle A prime, B prime, C prime. If I look at the coordinates of A prime is found at 2, -3. B prime is at 6, -2. And C prime is found at 4, -6. How do the coordinates of the reflected points, A prime, B prime, and C prime, relate to the original points? If you look at them, you will notice the x-coordinates of the points are the same. The x-coordinates are the same. They didn't change. The y-coordinates changed the sign. The number didn't change, but the coordinate became, in this case, negative. They went from being positive to negative. Now at the bottom, again, using the same triangle ABC, we now reflected it across the y-axis, okay? The y-axis being the one right here, runs up and down, okay? That's the y-axis. And I got the red triangle A prime, B prime, C prime. If I look at the coordinates here, A is found at -2, 3. B is at -6, 2. And C prime is at -4, 6. Well, how did those, so the next question B says, how did those coordinates compare to the original coordinates? Well, here, the y coordinates did not change. But what the x coordinates did. The x coordinates changed the sign. They went from being positive to negative. Again, I've got the triangle ABC. I now reflected this. I used GeoGebra to reflect this over the line y equals x, which I just graphed there. In the green line I just drew in. That's the line y equals x. How do the coordinates compare? Well, A prime is at 3, 2. B prime is at 2, 6. And C prime is at 6, 4. How do those coordinates relate to my original 3 points? Yeah, they flip-flopped. The x and y coordinates changed. The x coordinate became the y coordinate, and the y coordinate became the x coordinate. Next, last discovery here is I reflected triangle ABC over the line y equals negative x, which I just graphed there, that green dotted line. Look at the coordinates. A prime is at negative 3, negative 2. B prime is at negative 2, negative 6. And C prime is at negative 6, negative 4. How did those coordinates compare to my original? Notice all I did is I flipped the x, flipped the x and y coordinates. The x became the y. And not only did I flip them, but I also changed the sign. Okay? So they were positive, they then became negative, which leads me on your next slide, are the coordinate rules. So what did we discover? A reflection across the x-axis. The x-coordinate remained the same, the y-coordinate became negative, so it becomes x, negative y. When I reflected across the y-axis, we said that the x-coordinate changed the sign, so it becomes negative x, y. When I reflected across the line y equals x, I flip-flop x and y, so it becomes yx. And a reflection across the line y equals negative x, I flipped them, and I changed the sign, so it becomes negative y, negative x. So if I want to do example number 2, I want to take triangle M and P. M is at 1, 2, N is at 1, 4, and P is at 3, 3. If I want to reflect that triangle across the y-axis, if I apply the rule reflecting across the y-axis, the rule is the point xy becomes negative xy. So I'm going to take each x coordinate and change the sign. 1 becomes negative 1. 1 again, negative 1, and 3 becomes negative 3. The y coordinate does not change. It's going to stay the same. So my new points are m prime is negative 1, 2. N prime is negative 1, 4. And P prime is negative 3, 3. If I connect those 3 points, you will see the reflection across the y-axis. Classmate claims that the rule xy for negative xy for reflecting a figure across the y-axis only works if all the vertices are in the first quadrant. Explain why this reasoning is not correct. Well, just think of it the other way. If I would have given you, if I look back at this problem, if I would have given you the P prime to N prime is my original triangle, well, when I reflect it, the negative, the x's which are negative, would become positive. So, explain why this is the x coordinates will become the opposite. Okay? The opposite sign, they will just change. If they're positive, they become negative. If they're negative, they become positive. Your turn, go ahead. Give the coordinates. So if I'm reflecting over the x-axis, my rule is the x-coordinate will remain unchanged and the y-coordinate will become negative y. So s prime, which is 3, 4, will become 3, negative 4. T prime, 3, 1. X stays the same, y becomes negative, 3, negative 1. U. So u prime is negative 2, negative 1. X coordinate stays the same, y becomes the opposite sign, and v prime, negative 2, 4 will become negative 2, negative 4. If I graph those, 3, 4, 3, 1, and negative 2, 1, and negative 2, 4. Connect them, and then I connect the points. 3, negative 4, 3, negative 1, negative 2, negative 1, and negative 2, negative 4. Connect them. My rectangle here was reflected across the y-axis. The last major thing we're going to look at here is if I give you a triangle ABC, it was reflected to get triangle A prime, B prime, C prime. What I want to do is draw in the line of reflection. Remember, the line of reflection is the perpendicular bisector. Okay, so I want to find the line that's the perpendicular bisector of this line. So I have two options. Option number one is to find the midpoints of the segments that join corresponding points. So what I'm going to do is draw the line that connects A to A prime. B to B prime. And C to C prime. And what I'm going to do is measure those segments and find the midpoint of those segments. So if I connect A to A prime, so you will notice, so I got my ruler up here and I adjusted it to fit so your paper, so if you measure along with me, you should get within pretty close to the same measurement. I measured A to A prime. A to A prime is 2.2 centimeters. Well, half of that is 1.1. If I divide that by 2, I get 1.1. So the midpoint is going to be at 1.1 centimeters. So I find where 1.1 is. There it is. I made just a little dot there. Move my ruler. There's the midpoint of A prime. Next, I'm going to go and measure B to B prime. And you'll notice I get 4.4 centimeters. Well, half of that is 2.2 centimeters. So if I find 2.2, make a dot there to mark it. Make it a little bigger. There's my midpoint of B prime. And I will find the midpoint of C prime. C prime again, I measure that. I get 2.2 centimeters again. And half of 2.2, we already found to be 1.1. So I'll find where 1.1 is. Make a mark there. I'm going to move my ruler out of the way. Right there are the three midpoints of A prime, B prime, C prime. So what I will do is take the line and draw the line that goes through those 3 points. Now what you should do is take the edge of your ruler, okay, turn your ruler so that it goes through those points, and then trace the edge of your ruler. Okay, so if I move it right there, I would trace it to get it. How can you use the ruler and protractor to measure? Verify that the line, remember the line of reflection. It is perpendicular. It's the perpendicular bisection. So it's perpendicular and it goes through the midpoint of a segment that will join corresponding points. So connect A to A prime, B to B prime, and the line of reflection should be perpendicular to that line, and it also should go through the midpoint. So on your own, given triangle A prime, B prime, C prime, we want to draw the line of reflection. So again, I'm going to draw, connect the corresponding points. And then what I want to do is measure them. Okay? So, oops, I don't remove that. So, B to B prime, starting there, it's about 1.5. So half would be about 1.25. So it would be 0.75. So it's about right there. Measure A to A prime. I get about 4.5. Half of 4.5 is 2 1/4. So about 2.25. So make that about between 2.2 and 2.3. I've got C to C prime. Measure with my ruler, get 1.5. About 0.75 is about right there. So right there I did the 3 midpoints. I can then use my ruler to draw the line. So to make it so the edge of my ruler goes perpendicular to them. And then trace the edge of my ruler to show that they are perpendicular. And I should put arrows on the edge of the line because it doesn't extend on forever. Lastly, to give it a figure in its image, I can use the paper folding method. I'm going to talk about that. How do you draw the image of a figure under reflection across the x-axis, as we talked? So your homework assignment is, I gave you the handout last time in class. You should do numbers 1 through 5 on the first page. Okay, those are just from the handout. Follow the directions on the paper. On the back side of it, problems 18, 19, 20, 23, and 25 all come from the book, and you can get those in the book and check them out there. Thank you. Enjoy. Remember to submit and everything on Schoology. You're actually checked and not. And if you have any questions, we will talk about them at the start of class next time on Tuesday. Thank you.